Thanks and welcome everybody to today's presentation. So thrilled to bring to you an overview of RWI Synthetics and the work that they did with us on this challenge area for Incubate Energy Labs Challenge and the 2020 cohort in conjunction with Salt River Project utility out of Phoenix, Arizona, and Gary Rector, who is their data science lead there. So with that and without further ado, we'll jump right into it. And it's my pleasure to introduce Myrna Bittner, CEO of RWI Synthetics, to walk us through the project. Myrna, thank you, and the floor is yours.
Thank you so much, Annie. Just an incredible opportunity for anybody who has a chance to become involved with EPRI through the Incubate Energy Labs Challenge. This is my company. We're coming to you from Western Canada, so Edmonton, Alberta, Canada today, where it's kind of snowy. And really a profound opportunity to exercise what we have been up to in the area of modeling and impact modeling. Special shout out to David Case, who is also a fellow Albertan, who is here today, and he was the one who sent me a little email way back earlier this year saying, hey, Myrna, there's this Incubate Energy Labs thing I think you guys would be perfect for. And that cascaded into where we are today. So really what my company does is in the area of what we call synthetic modeling. And that I guess will become clearer as we go along. And I'll just take you into a little bit of a background of what my team does. So our company is heading into almost its 7th year. We didn't start into the city space until last year. And really this was the first few years of the company. We were really focused around building these synthetic models around very complex global digital systems. So it took us a while to kind of realize what we were doing when we were building these models around these digital systems. These digital systems were everything from AT&T's global addressable advertising system to in-vehicle device-based systems. But really, we were creating this ability to interact and intersect and create realities for these systems that they hadn't faced yet in the field, because their systems were growing so complex. There were so many dynamic edges to them, and there was so much emergent behavior in these systems that they were really finding challenging to get ahead of, and often failing and scrambling in the field to react and respond and try to figure out. And so this is after a long background in artificial intelligence and automation systems, where my company started almost 7 years ago. Like I say, our evolution into the city space has been rather recent. So starting in 2019 was when we were asked by Itron, so a utility technologies company, to take what we had done in geospatial and human behavior and activity and dynamic environments and actually create a synthetic Silicon Valley and put it through an earthquake. So implement their technology in this in silico space, populate it, and look at all different kind of aspects and characteristics of everything from building construction to utility layout, and then create a live earthquake in this environment and understand how their technology could strategically impact resilience for the city. And this, it was great. It was the keynote for the IoT World Expo in 2019, and really propelled us into cities are complex systems, and they're full of the same edges as digital systems, so people and environment and interconnected systems. And they're likely suffering the same kind of disruptions in scale, disruptions in new technology, and we could characterize those as well. And so this, we happened to choose energy as one of the fundamental layers of disruption in cities. The challenges that the grids are facing as they approach and are approached by all different kinds of new technology, from their edges and electrification, cybersecurity, climate change, And we thought this would be a really interesting kind of modeling environment to flex in. So after creating a city that was, it was our own city of just over 1 million people, spinning it forward to 2035, and we added not only the grid infrastructure, but all of the electric vehicles and vehicle to grid technology, battery to home technology. We were really wanting to experiment with in a live environment how these technologies would be utilized and their impact and intersection with grid assets. Was when we felt that it was an okay time for us to put our hand up for the Incubate Energy Labs Challenge. And I'll go forward and explain a little bit more about what we did in this project. So this is kind of a spoiler alert, some of the metrics around our actual environment that we produced. So showing the end before the beginning, but we joined up, as Annie was saying, with Salt River Projects and chose a certain area, a service area to focus in on for this project because it was a very condensed timeline project. And this area involved an area of Phoenix and Tempe and 18,000 households, about 2,000 businesses, and upwards of 140 separate models. And the idea was to create a better understanding of a dual disaster. So COVID-19 being one of the aspects of the disaster, and then a power outage during COVID-19. And we chose to do this, picked a day on July 15th because our models are really quite exact in the time of day to characterize the activity during that power outage. And now I'll kind of take you through a little bit about how we do this. So what's underneath these models and these single synthetic environments is really geospatially accurate digital model of the city or the service area or the region. It includes the physical infrastructure, really whatever is relevant. The utility layout in this case was really relevant. The residents, the businesses, the aspects of the disaster. So in this case, we chose not to include physical damage in our outage. This was due to a couple things. We were assured that beyond the windstorms, sandstorms, valley fever, and some flooding and the minor earthquakes in Phoenix, that really they didn't have any major problems with physical disasters. So we thought, well, and since their emergency services were rather busy when we started this project in a pandemic, we decided to model non-physical kind of disaster outage and to really get a good focused look at what's happening inside the city at this time. But we also can model technologies, so existing and anticipated, things that are under consideration, and even model the human-machine interface of those. And really one of the most fundamental aspects about our environment is the people. So we characterize a variety of modeling techniques. So we aren't particularly married to any one. And we really choose the modeling techniques depending on the data that's available or the behavior of the entities that we are trying to characterize and the research that we need to incorporate, as well as even connected to other models that are available. And this is kind of an example of how this maps out. So this is, a slice of, our architecture and the particular combinations of models in this project. So we had everything from consumption models to aspects of outages to human behavior modeling to even resilience inflection points and investments and techniques. The synthetic population is a really kind of, that's highlighted at the bottom left corner because that's really an area where we spend a lot of time. And then looking at the commercial aspects of businesses in the area and even factors of note, as we call them, so other models such as the Department of Energy's interruption cost estimate calculators. And then we have a lot of processes that we use to validate these models and their interconnections because we are dealing with emergent behavior. Some of them involve having the models actually visually check themselves and all of their interconnections. We spend a lot of time assessing the results of our models against third-party research and research that we haven't included to use in the models themselves. And really, when we approached this project, we saw three kind of strong narratives: the people, the community, and the utility. And there's kind of this starting state, state during the outage, and then after the outage. And so these are kind of some of the themes that we followed through when we were characterizing those different aspects of the modeling environment. We started first with really synthesizing the grid. We're used to synthesizing actual up and operational systems, and so this is where we started, and really looking at how consumption had changed during COVID. And this is an example of looking at the businesses and the different types of businesses in the area and looking at how their consumption curves varied depending on the movement of control orders, and even the variation in the percentiles of these different businesses in the area. And then, of course, in this project, the lights were out. So we wanted to demonstrate, because it was a proof of concept project, that we can model the physical nature of the grid and the capacity from the demand side and all of the grid assets. But then really to understand for us, what were some of the fundamental things that happened with the systems that were still up and going after the lights went out, primarily being the people in this area. And one of the fundamental kind of forward-looking things about energy and energy transition and some of the disruptions that are happening with energy is really this necessary engagement with the customer, and that customer is going to be participating in the future success of their grid. And the underlying thing is we're all learning more about, even through this pandemic, is the importance of trust in this engagement. And so that was kind of, where is the starting place for utilities in this trust relationship? It made us smile, and we all shared a little bit of a giggle when tech startups were just slightly ahead on the trust aspect than utilities. So we can collaborate and help each other out there. And another really important aspect about this engagement or trust is an understanding of how people value reliability. So some refer to this as willingness to pay. And there's been a lot of study that's gone into how people value reliability based on, who they are, their demographics, whether or not they own properties or rent them, the number of kind of outages or prior experience they've had with them, even whether the outage is determined by storm or unknown causes. So really, there's some really interesting research that we were able to include to inform the population in our area of study. And given a bunch of these kinds of factors, this is really what we were setting out to do, was to synthesize the population. They are the active system that when the power goes out is still in operation. They're in their homes, they're trying to work. Some of them, especially during this aspect of the disaster, which was during COVID, they have health conditions that need to be considered. Some have caregivers, some don't, and some are really reliant on power because they're pre-existing conditions for things like oxygen. And all of these conditions are impacted by the stress during an outage. We also wanted to look at all kinds of aspects of their household, so understanding who in the area might have access to backup power and generation, a fundamental kind of going into this scenario, understanding of where their trust level or engagement with their utility was at. And we had to pull in all different kinds of information, once again, that's publicly available from research, consumer surveys, domain expertise to create this synthetic population. So this is an example of some of the aspects of data when it's overlaid geospatially. We pulled in property values and types from Maricopa County data, looked at the relationships of different types of residences, where they were located, the different types of family groupings that will be living in those residences, the types of businesses. So there is a whole raft of different types of businesses with different consumption patterns and economics also in this area, where they were located. So that sometimes can be really important to get that geospatial understanding of where these businesses are and what power they're consuming and how outages will affect them. And then began to characterize things of even more detail, such as the income associated with a property value, the segments or location of income segments in this area, so that we could characterize even more closely or with more accuracy. Oh, sorry. Okay, can you still hear me?
Yes, we can, Myrna.
I got lots of stuff going on here. There's all of a sudden I'm really popular with my phone. No, high income, so different demographics do have different experiences with outages, and different, it affects them in different ways, especially during COVID, when there's differences with who is able to work at home. So really, we can, kind of detail what is completely never identified, never surveilled population we can create synthetically in this environment. And we can use this population to ask some questions and to study their behavior without kind of that feeling of that we are gaining too much access to personal information. So it's a great way of being able to study what happens. And to get even in more detail, we reached out and joined the SECC, so the Smart Energy Consumer Collaborative, and they have been doing just profound work over the last, we were looking at 7 years of pulse wave data, where they have segmented their population and in their engagement with the power company. And we can look at and apply those segments to this synthetic population after synthesizing it and getting all of that access and information about relevant demographics. And then we can begin to look at how their engagement is with their power company, and who has interest in some of these self-sufficiency programs like generation and backup power, who is aligned with solar or electric vehicles, who has interest in engagement with the power company, even about outage alerts. So the information becomes really vast that we can layer onto this population in modeling and then bring to life for study. And this can just keep going on and on. We can even, kind of understand who's going to be adopting electric vehicles in case in the future we wanted to, in this scenario, understand what the implications of vehicle to grid technology might be in a resilient environment, for example, where they could do grid islanding and use electric vehicle batteries for their home. I'll just move on from there. And once again, the whole purpose of this was really to create a really as accurate and detailed of a human system understanding behind this, so that we could then begin to calculate the impacts on this human system when the lights were out, and use that to understand the importance or the value of inflections and investments in this outage. And as I talked about before, engagement and trust are some of the big fundamentals. So how people's engagement might change with their utility company during an outage. And we can look at that even by consumer segment. So over the course of time, what different segments might change their engagement with the power company, how that would change for different segments over time, and even look at the stress for a number of cumulative factors for the population in this area, and use that to really inform the response of the utility company. And back to this willingness to pay, this was a really interesting study that we incorporated. We have a variety of ways of using neural nets and proprietary filtering techniques to take even very aggregate data for studies like this and to be able to assign it and layer it to specific households so that we can get answers or to even survey questions in our environments from those households, even though the households don't actually appear in specific demographics of the aggregation, if that makes sense. But here's some of the results that we see when we are able to put these studies into these synthetic populations and then watch as they undergo an outage. And some of the really interesting things are the discontinuous things that happen. And for example, how trust changes over the course of time and how trust may be also inflected. So in this scenario, we ran some separate runs with different effectiveness levels of utility communications and found that there was some dramatic kind of shifts over when the communications were good versus poor, and even specific differences for vulnerable populations from good communications to poor communications. And vulnerable populations being populations who are medically or economically disadvantaged, and especially during COVID. So they might even be in the categories that were at high risk for COVID or even had COVID. But we can look at how those combinations of factors compound. And these might be really important areas to address as a utility or to look for other partners to invest in, how we reach or how we understand those vulnerable populations and where they are and what inflects their experience or will help them through these outages. And willingness to pay, again, was another one of the discontinuous types of behavioral effects that happen, so psychosocial kind of effects during the outage. And the differences between good communications and poor communications there weren't really well described as groups, but there were different segments that kind of stood out as having an effect of the willingness to pay. And again, these are some of our what we call our delta graphs. So when we would do a run where there was poor utility communications, and we would look at the effect of trust on the population. We could also then do a run where there was good communications and look at where there was the most improvement. So which areas of the city and the population had the most improvement, and map that delta and then really kind of drill deep into the whys around that delta. And this led to, again, some interesting aspects of how this might be applied. And one of these being when we looked at vulnerable populations through this environment, how this might be able to map to the service area and then really be able to look at how that might change repair priorities. So here we were mapping vulnerable populations and actually then creating outages and understanding, compared to existing repair priorities, how those might shift, especially during a pandemic. And of course, our models you know, on those three narratives are, you know, not only about the people and an understanding of the utility and the implications for the utility, but also looking at society and societal costs. And I think in resilience calculations, this is also really important when we look at how important it is to address and minimize the impact during outages and add this kind of understanding of economics. And I know economics is really something that is debatable. There's been a lot of work around calculating GDP loss, and really there's no kind of one perfect way. But the interesting part about our models is we're able to incorporate a vast number of ways of looking at loss and during outages, and even based on consumption. So we're able to look at what happens, what would have happened if the power would have been on, the delta and gap between that, and then really look at how businesses are currently consuming and what their consumption patterns would have been during this loss of power, and then begin to apply a whole variety of different external models. So part of the modeling that we included was the interruption cost calculator from the Department of Energy. That can be one of many that we include. We also included our own models of how much power people were using that had shifted during the pandemic, and then the different types of businesses and their surveys that have been done previously about the size or the scale of losses. We can then map those to these environments and understand, and maybe even use that to change repair priorities or understanding of resilient impacts and targets for investment. So here's kind of a static view of what was going on there in the movie. But really, the calculations and the analysis are limitless. These synthetic environments, we can instrument them in any way that we like and gain data and kind of unprecedented access to data. And so we're able to, after the fact, we have these massive kind of data stores that we're able to pull anything that we want for analysis. And this is an example of looking at a variety of different business loss calculations, including the Department of Energy, and very specifically for the SRP service area, for the businesses, their sizes, their operations in this area, really a hyper-localized perspective on loss that can be applied to any city or any area. And one of the important parts about doing this as a live environment is really to also then be able to model changes in value over time. So no city is static, every city has experience, and it's really important to kind of be able to project that or play that forward. People say, you know, that you're modeling the unprecedented, and we are. Modeling enables us to do that. But there is also other precedents that we can pull in when we're modeling the change in people's behavior or in cities or in systems over time. And so one of the important things that we looked at was GHG emissions. And you wouldn't think that GHG emissions would relate to outages necessarily, but almost every city has some really quite strong GHG emission reduction targets now, especially when they look at utilities. Phoenix being among them, they have been growing as a city, but they have actually been reducing their GHG. And so we wanted to also understand how outages and GHG went hand in hand. And where we found this to be relevant was that there was a significant number of businesses in the area, in particular, that had already backup or auxiliary power in place. And none of it really is GHG emission friendly. So this was an important part of understanding outages and the time of outages and the length of outages and the extent of outages was the GHG emissions from this power source. It became particularly relevant, I think, in California during the fires and the outages during those fires. How much this generation or self-generation of power using fossil fuel sources was contributing to their contaminants as well as their GHG targets. It was actually impacting their targets. And so we thought this would be interesting to not only look at what types of businesses in this area have backup and auxiliary power during the course of an outage, how much GHG would that be, what would the impact be, but then also begin to look at if there was a series of or a sense of intermittency in power or that there were several interruptions in power, how these businesses might respond over the course of time. And so we were able to map based on some survey data that has already been done, who and how many businesses and what types had already made the spend on auxiliary and backup power, who was planning to spend, who tried, and who had no plans. And this was really important, I think, because there is this addressable market of people who have already spent or those who are considering spending to be approached and potentially engage in more environmentally friendly or less GHG emission backup and auxiliary power investments. And we can calculate the delta of or the opportunity based on, we use the example of California where they have, their businesses have suffered losses and have now kind of assessed the difference between interruption insurance and versus looking after their own backup or auxiliary power. And there was about a threefold increase in the number of businesses with backup and auxiliary power, and most of that being fossil fuel based. And so we were able to project forward and also calculate the amount of GHG emissions for residents as well as for businesses if they continue to sense this this challenge to their power and assess it as being a worthwhile investment. And this, again, we also looked at portable generators and stationary power for homes. And this we also found to be an impact of COVID, that when people are in their homes and they're productive in their homes and they're in an income category where they are able to look after their own power, might be an important trigger in the future to also ensure their power supply and their power stability. And there could be an opportunity to engage with a power company to make that happen. And this is an example of that. So we could actually chart the types of homes and the types in our synthetic population of people who would be working from home, their income levels, and then how that would map to their existing access to stationary or backup power, all the way from portable generators from their RVs to stationary power attached to their home, and look at the range of likely people who would be targets for investing in that. So this is an example of the live interface that we put on it. As you can see, you know, I kind of left it to the end because it was really less important in this scenario to have a live interface over the course of a power outage a scenario than it was to be able to look at the data after we did these runs and we made the inflections and changed communication at COVID levels. And that we really wanted to be able to, though, demonstrate that for stakeholder purposes, which is really important for some of our use cases, that we are able to put live data interfaces and environments on that can really enable you to scrub time and very quickly adjust factors and look at everything from consumption to economic to medical conditions, who has what critical aspects in their home, such as backup power, and etc. And the whole purpose, I guess, of us and for being able to approach modeling and critical kind of future impact issues is to create these environments that are adaptable to the scenarios or the issues that need to be addressed, that are very additive. So we welcome stakeholder participation in these environments. We welcome additional calculations, simulations. We work with universities and research departments, as well as national bodies, and that the results that we're able to deliver are very focused on being actionable and calculations that can actually make an impact in investments, in quantification and understanding of preparedness, the assessment of readiness of systems, or even accelerating pilots. So there is a lot of technologies coming out in this space, in edge technologies for managing grids and managing new adoption of technology on the consumer side. And it's really challenging to be able to understand in such a large and very environment. So that's part of the reason why we exist, is to help people through that. And I know in the utility space, just as many others, there are a massive amount of initiatives underway to really get data ready. But we have kind of said, why wait? And that sometimes the data that people are relying on, the answers being in, isn't sufficient, or it's historical, so it doesn't give you the proper context for things that haven't happened yet, or new technology adoption, and that really relying on surveillance sometimes limits what you can see. It's kind of ironic, but you can't always see. And I use the example of, if you put a sensor on a street light to sense contaminants, what you get is data from the contaminants that actually reach that sensor. You don't necessarily get data on the contaminants that are being emitted by the vehicles on a windy day when the contaminants don't reach that sensor. And whereas in modeling, you can actually calculate the congestion factors, the mode of transportation, the engine size, the contaminants that are being released. It's a different way to understand the world without that kind of access to surveillance data. And kind of liberating when it comes to being able to model things that haven't happened yet. For this project also, I should mention, because of the condensed timelines, we weren't able to access SRP's regulated or privacy protected data when it came to their grid assets or their customer data. So we were able to, from the demand side, model and synthesize models that could be, that produced data that was then validated by SRP, but we relied exclusively on our models and the demand side to create them. And these are some of the projects that we have underway. These are all kind of connected in a way, as we're discovering, but really around disaster response and preparation. So how to design those systems, how to run those scenarios. So once again, hearkening from our digital days, you don't really know what's going to happen until you experience it. And so we can experience these scenarios through a synthetic environment, a limitless number of scenarios, and really validate the systems that we've put in place, and even in far greater detail. So understanding all of the ripple effects and impacts around those decisions that we're making, or those systems that we're deploying, and looking to design those better outcomes, just like we had gained that understanding through experience. We weren't expecting a pandemic to be amongst one of those disaster responses, but but that has led to some really interesting work, even in our mobility work. So we are part of the City Architecture of Tomorrow Challenge with Toyota Mobility Futures and Deloitte, and really designing and redesigning, even now that the pandemic has hit, how people make those choices about their modes of transportation, their electrification of transportation, public transportation, suddenly people and how they interact with those choices have become really important to planning or redesigning and adapting very quickly to new scenarios. And we can do that in our synthetic environments, as well as the future of electrification. So now there's getting to be even more understanding amongst people, even in transportation departments, about how their plans for their electric vehicle corridors intersect with utilities and intersect with disaster response. Because as we electrify transportation, we also, in ways, make ourselves more vulnerable if we don't think it through about how we can ensure that those systems are resilient so that we can continue to transport those goods. And as well, we have just a ton of work to do when it comes to looking at new tech adoption in cities and who's going to be getting electric vehicles, what streets are they likely to live on, what transformers or grid assets are going to be at risk, how can re-engineering things behind the meter, lead to better resilience or assist the utility companies in some of their peak issues with power generation or the introduction of renewables, hidden load, a whole bunch of kinds of aspects of those we can model and look at what technologies are needed and the combinations of those behind the grid or behind the transformer rather. And so this is kind of the culmination. I wanted to leave time for questions of our project through the Incubate Energy Labs. Like I say, it was an amazing, I think we had 10 weeks of activity and a week on either side of presentations and introductions, but just a fantastic opportunity to be able to transfer kind of what we do into the world of energy and energy research and energy transformation and resilience. And can't thank the program organizers enough for this opportunity.
Hey, Myrna, thank you so much. And I just ask, so Gary Rector, who is our lead from SRP, is also on the line. So, and what a great presentation, Myrna, thank you. So to say, if you are wanting to ask a question, just go ahead and unmute yourself and go for it. And Hannah, if you want to help kind of moderate us, that'd be great too.
Hi, Myrna, it's Parth from Umlaut. Great presentation. I just had a quick question regarding your participation in urban mobility. Has Run With It done any simulation on how the urban mobility is being perceived by different countries? Has anyone reached out to you for a project at that level? And when I say urban mobility, I mean, for example, electric scooters, which are becoming really, really big in all the metro cities. They're becoming big in New York. They're becoming big in Germany, and Canada is, I think, next on the line for the introduction. Especially 2021 is the year when, for example, Spin from Ford Mobility is going to be launching their scooters in downtown Toronto. Have you guys done any sort of project on that side?
Not specifically with e-scooters, but as part of the City Architecture of Tomorrow, we have been modeling micromobility. And we have done some quite extensive studies into electric scooters. And we would love to be able to do a specific project because the ripple effects around those scooters, the demographics of who uses those scooters, the environmental impacts, the health impacts, The sidewalk congestion now has changed, and the human behavior around pedestrian journeys. And so that would be a very interesting kind of specific study to do in just the implementations or deployment of e-scooters. But they do form a part of our micromobility environment in the City Architecture of Tomorrow Challenge.
Absolutely. Yeah, I think that would be a very interesting way to go, because due to COVID, public transportation is being used less, if anything, and all these smaller, separate modes of transportation, multimodal transportation is coming up. But yeah, great presentation once again. It's Part from Umlaut. It's great to speak with you.
Thank you, Par.
So there was a few questions in the chat, but it looks like most of them were answered. Myrna, I'm not sure if you can open up your chat and check. It was between Gary and Jennifer. They were just talking about, Gary had a comment, RWI Synthetics was able to impute our electric load curve without having proprietary meter data. It looks like Jennifer commented that this is super interesting. Have you been able to compare simulated results to real world results, especially regarding the people and customer findings?
And yes, we have. So one of the kind of aspects of being able to include the survey data, for example, and the impacts of outages is that we can also map back our outage impacts to those aggregate surveys and that survey data. So it's part of our validation process is to be able to look at third-party research that was done, maybe in different areas, and see how our models and our results compare. So we can take that and use that as, yes, comparing our results to real-world scenarios. And then I'm going to look. Oh, I see Gary responded about good communication and that SRP had confirmed that it did improve the trust of their clients. Did anybody else have any questions?
Actually, this is Jen Robinson. I'll expand on my question as well. So I asked the one about comparing simulated results to sort of the quote unquote real world results, which is super interesting, especially with SRP, right? Because they have so much research that they've done, their own customer research. So I was wondering specifically, so for example, you mentioned you could identify potential electric vehicle adoption. I would imagine the SRP probably has some information there. So have you been able to compare down to the SRP level? Sounds like certainly on the comm side, as Gary responded, but just curious about other validations that you've done.
We didn't have a lot of access to SRP's internal research as a result of this project, but I'll let Gary respond. I see he's taken himself off mute.
Well, Myrna, you actually had no access to that. We made it really hard for you, and your team rose to the challenge. But specifically for EV and PV, those models that we've done internally are still being vetted. The 5-year projections are just we're not that confident in yet. Everything's changing too fast. But what we did see that gave us great confidence was that the load curves that your team produced matched almost identically with what our dispatchers use. It was amazing. Frightening, frankly. It was good.
Not frightening.
Well, yeah, in a good.
Yeah, but I think Jennifer, that's one of the hard parts about what and the differences, I guess, between us and predictive systems is that we don't set out to necessarily predict. we set out to make that kind of future happen and make sure that we have included opportunities for changing variables to be introduced. So, for example, when the economic impacts of COVID are being felt, that's also changing how people are considering their purchases of new vehicles or investment in new vehicles. If I'm working at home and really traveling nowhere, I'm unlikely to go out and make a significant investment in a new vehicle at this point. And so we can include those very quickly, those changing models and perceptions of consumers in our models, and then continue to forecast forward versus other models that may, be derived on prediction, and they're forecasting, and they haven't been able to flex as quickly to some very dynamic conditions, either in the economy or in the health or in the world.
And that's why I like your message very much. Thank you.
Thanks, Gary.
Okay, do we have any other questions? I don't see anything else in chat right now.
Hannah, I had my hand up. This is Bruce Williamson.
Oh, sure, go right ahead.
Okay, let me start the video. I had to step out for a couple minutes as we got into the Q&A portion, but so I apologize if you've already covered this. I'm a regulator in Maine and an economist and a modeler by profession. And I had started down this very similar path to what you're doing, but more of a metric approach. And then with storm resilience and private investment versus public investment or utility investment, and then had to back off that in the last 2 years because this has become open dockets, and I can't be communicating with utilities during these open docket issues on storm resilience. But I find the presentation fascinating. I really appreciate it. A couple questions. One is, how much time did it take for you from the get-go, this is what we're going to do and a clear project definition, to the stage you're at now? What's the elapsed time? And secondly, did you look at the interaction effects between the incentives and the cost of private investment in self-sufficiency or self-insurance versus that of the utility? And the interaction that I was interested in is, if the utility knows that 90% of the customers have generators or backup storage for 8 hours, it might reduce their incentives to get the crews out to bring power back up within 8 hours, or to make the investment in hardening their above ground facilities because they know that customers have self-insured. Have you looked at that? And then the first question was about the time length.
Okay, and thanks, Bruce. And I'd love to connect with you too, and find out more about your world. We're just learning about this one. So I laugh because from the start to the finish of this was 9 weeks, really 10 weeks. So it was like, where is Phoenix? And Gary laughs at me because he says that, every Canadian should know where Phoenix is. Half of you live here. No, I've never been to Phoenix. So first few weeks we're diving, some parallel efforts, diving deep into, what are Phoenicians like. We learned about things like valley fever and the fungus among us, as Gary calls it, that affects, respiratory rates, to do with storms, everything that we could while synthesizing their grid assets from Google Earth. So, that's kind of the speed, and this project was complete, and as you see it, and there's a lot more behind it as well in the basically 9.5 weeks. Along with, a series of presentations every week that we did to the group, and then a final demo day. So it was very compact, and that's one of the accelerators of our model. We have since then kind of halved our time in approach as we moved on to a mobility project for the city of Kuala Lumpur. And so we accomplished probably even more in less than half the time in extending our models to mobility. So it's a super accelerated process that we have. In terms of your second question, in terms of the looking at the investments, and yes, it is a very complex investment picture. We did a very short outage of 6 hours, and knowing that there are some really interesting decisions and combinations of decisions to be made when there is a population that has looked after their own power and backup and auxiliary power. There is an opportunity in this population that they missed, I think, in California, for the utility to become involved in participating in that investment with their citizens, and being able to be the one that helps them make more renewable or environmentally friendly decisions, and that can be, I think, tied to resilience investments, which resilience investments are not if the power is going to go out, but when it does, how did we as a utility minimize the impact with the investments that we've made on our population? And I think it's really important now, and I think almost every utility is focused on how we actually calculate that impact. So it may mean that, yes, community resilience might mean that we change how we repair differently if we know that there's neighborhoods that are looked after, but that's good, isn't it? That there's neighborhoods that are looked after. And so we can actually pay attention more to how we align the vulnerable populations and make sure that they're looked after also, and shift or change that investment. But yeah, it's very complex with the willingness to pay, people's income levels, and their ability to look after their own sustainability.
Yes, and thank you very much. That's a good answer. The one other, it's just an observation, is that in the U.S., and I think it's equivalent in Canada, there's emergency management agencies that are like our federal emergency management agency you may have heard about during the Katrina issues in 2005 with hurricanes, but each state has their own. And indeed, each county and town may have an appointed person. And they get involved from a policy standpoint in setting priorities for restoration. So it's not just the utility that gets to decide. Often the utility is responding. In one outage in Maine we had, we discovered that a cable provider was the majority provider for broadband to school polling places, and the outage occurred 2 days before Election Day. So someone else had to be brought in, a company that's not regulated had to be brought in and talked to about reprioritizing getting their broadband system back up, the fiber system. And the utilities in the meantime were kind of put in the background because you can't reschedule elections very easily. So this is where the state officialdom gets involved, often reprioritizing what a utility might think is, electric utility might think is the most important thing for them to do. But that's just a comment, an observation. Thank you very much. Excellent presentation.
Thank you so much, Bruce.
All right, I know that we are at 1 o'clock Eastern time. Annie, do you want to close this out?
Sure. I would say that we can put you directly in touch with Myrna, or if you'd like more information about RWI and follow the company. They've got a very active social media presence on LinkedIn and also Twitter, but feel free to reach out to me. I'm at ahaas@epri.com. That's AHAAS at EPR epri.com. Just thanks so much, everybody, for joining us today. And we're going to be doing more of these lunch and learns. So stay tuned. We'll be publicizing these. And, I think, and there's Myrna at runwithitsynthetics.com. We've also recorded this presentation, so can make it available for folks that may want to see it after the fact. And with that, Myrna, thank you. Gary, thank you. And to everybody dialing in today, thanks so much.